Alright, here's the video key for the 5153 wrap-up, just so we have me working through these questions for you guys. So the first one is a square root. In order to solve this one, we need to find perfect squares that come out of it. Specifically, the perfect square that comes out of 48 is 16. And then that would be multiplied by 3, so square root 16, square root 3 makes 48. Square root 16 will then become 4, so our final answer would be 4 radical 3. And that's as far as you can simplify that. For number 2, because it's a cube root, now we're looking for perfect cubes. So perfect cube that comes out of 135, calculator. 135 definitely divisible by 5, but definitely not 125. So 135, if we divide it by 5, let's see what we get. Ooh, 27. So 27 cube root of 5. So that's going to be 3. So that's 3 cube root of 5. All right. Number 3. So negative 128, we're looking for a perfect cube that comes out of that. So I take 128, I'm going to divide it by a small number, so like 4 maybe. Yes, divisible by 4. So 128 divided by 4 cubed is 64, so let's divide it by that. And we get 2. So this is the cube root of negative 64. Make sure the negative goes with it. And then the cube root of 2. So that's negative 4. Negative 4 times 2 would make negative 8 cube root of 2. 512. So trying to find the perfect fourth power that comes out of 512. Let's again just take 512 divided by 4. That's 128. So 4 to the fourth power would be 64 times 4. 256, too big. Okay, so 512. Oh wait, not too big. 512 divided by 256. Let's see if that works. Oh, it is. So it's the fourth root of 256. Fourth root of 2. I don't know why I missed that one. So that's 4. So 4 times 3 gives us 12. Fourth root of 2. All right, number 5. So number 5, we have the fourth root of 324. I know that here we have the fourth root of 81, and that's specifically 81 times 4, okay? And then a to the 7th is not a perfect fourth, so we need to split it up. Here, I'll use a different color. A perfect fourth that comes out of a to the 7 would be a to the 4th power. A to the 4 times a cubed is what gives us a to the 7. That a to the 4th will then just become a. And lastly, we have b to the 24. B to the 24, 24 divided by 4, gives us 6. Fourth root of 81 is just 3. So then everything outside goes together, 3a and b to the 6th power. And then everything inside also needs to go together. So the fourth root of 4a cubed. And then there's our solution. All right, number 6. So we're looking for perfect cubes that come out of 216. 216, we could just start dividing it by perfect cubes. Not 81, 216. Actually, 216 divided by 64. Nope, so not 4 cubed, so 216 divided by 3 cubed would be 27. There it is, 27 and 8. Oh wait, 216 is just a perfect cube. I forgot it's just 6. So this is just negative 6, right? X to the 5th power is just, we need to go cube root of x cubed, which would leave cube root x squared. And then that y has to stay inside. So y would stay. So we have negative 6 times 3, which makes negative 18. That x also comes out. And then on the inside, we have the cube root of x squared times y. All right, and then there's our solution. Next up, so just convert to radical form and then simplify. So if we're converting this to radical form, this would become 1 over 4 to the 3 halves, which would give us 1 over, and then this is 4 cubed square rooted. All right. Probably a little bit better to write it square root of 4, and then that's getting cubed, because the square root of 4 is just 2. So 1 over 2 cubed, which gives us 1/8. Number 8, we got negative 64 to the 4/3, so that's going to be negative 64 cube rooted raised to the 4th power, which cube root of negative 64 is just negative 4, so negative 4 to the 4th power. Negative 4 to the 4th power, oh, we just did this one. 4 times 64 is negative 256. Or not negative, sorry, positive, because it's an even power, so the negative would go away. All right? So that's 7 and 8. Next up we have 9, okay? Number 9, we have x to the 1/2, we have x squared. So that x to the 1/2, we need to combine it with x squared. So we need to make squared into 1/2, so that's just multiplied by 2 over 2. So that gives us x to the 1/2 multiplied by x to the 4 halves. 4 halves plus 1/2 gives us x to the 5 halves. All right. Gosh, that's probably good there. You could technically simplify this, right? So x to the 5 halves would be x to the 5th power square rooted. So that's square root x to the 4 square root x. So that just becomes x squared square root of x. All right. Wait, we wouldn't want to simplify that. We would want to keep it in its fractional form, right? X squared square root of x is literally just taking us back to this, all right? So we just leave it x to the 5 halves. That's what we want. We're just combining those together, all right? So number 10, right, they're already common denominator. We can just add them. So that's going to be x to the 9/3. You reduce 9/3 to just get x cubed, all right? You would want to reduce if reducing is possible. In the previous case, right, 5 halves, you can't reduce that. So don't worry about reducing. All right, 11 over the 4th root of 11. So I really like the method where, okay, we have a 1/11. We would need 4 11s multiplied together. So we need the 4th root of 11 cubed, because 11 cubed times 11 would give us 11 to the 4th. So we multiply the top and the bottom by 11 cubed. That gives us 11. 4th root of 11 cubed over 4th root of 11 to the 4th power, so these cancel, and then we're just left with 11 4th root of 11 cubed over 11. The 11s then cancel, so we're only left with the 4th root of 11 cubed. All right, and you could definitely multiply out that, but I think that's great just right there. Okay. Yeah. Coming over to this side, I actually realized what I maybe should have done for that question now that I'm looking at this next one. You have 2 and you have 1/2, right? Both of the bases are the same, so we can actually just subtract that. So this is going to be x to the 2 minus 1/2. 2 minus 1/2 is really 4 halves. So 4 halves minus 1/2 is going to give us x to the 3 halves. All right. We definitely could have done that in the last question. We didn't need to rationalize the denominator like that. You have 11 over 11 to the 1/4 power. That's 11 to the 1 minus 1/4, which gives you 11 to the 3/4, which is the same thing as that right there. Next up, 13. 13, we just multiply here. So you multiply the tops, multiply the bottoms. So that gives you x to the 10 over 15. Reduce that down just a little bit, right? So it's going to give us x to the divide by 5 on both, which is 2/3. 14, again, we just multiply, so 2 times 3 gives us 6 to the 6. 3 times 4 is 12. 6/12 is just 6 to the 1/2 power. And then we're good right there. All right, these next ones. So these next ones, it's kind of nice to simplify them first, in my opinion. You could, by all means, multiply together first, right? But if you simplify, you're just working with smaller numbers. So 4th root of 16, and then the 4th root of 3 here. 4th root of 16 becomes 2, so 7 times 2 gives us 14. 4th root of 3, that's getting multiplied by 3. 4th root of 8. 3 times 14 gives us 42. So this becomes 42. 4th root of 8 times 3 gives us 24. All right. All right, next one. So this next one is kind of challenging. The reason this is challenging is because these radicals are different, so we just can't use them right away. Instead, we need to first make them the same radical. The easiest way in my mind to do this question is to say, okay, we have 5 multiplied by 64 to the 1/4, and then that's getting multiplied by 2 times 8 to the 1/2. All right? It's easiest to make that 1/2 into a over 4, so let's multiply by 2 over 2. So that gives us that same thing, 5 times 64 to the 1/4, multiplied by 2 times 8 to the 2/4. Well, 8 to the 2/4, that's 8 squared, so it's going to be 64, right? At this point, you could rewrite it into its radical form, so take it back to radical. 5 times the 4th root of 64, multiplied by 2 times the 4th root of 8 squared. Go from this point, we see that it's 5 times 2 gives us 10. And then we have the 4th root of, this is 64. Actually, I would want to simplify both of those first. This is also 64. So what comes out of that? We have, 16. Yeah, 4th root of 16. And then that's the 4th root of 4. So both of these simplify the same. 4th root of 16, 4th root of 4. 4th root of 16 is just 2. So we have just 2 on both of these. I need to make this smaller. So erase this step right here. So we have 2 times 5 gives us 10, 4th root of 4. 2 times 2 gives us multiplied by 4, 4th root of 4. 10 times 4 is 40. 4th root of 4 times 4 is 16. So that's really 40 times 2, which then gives us 80. All right, number 17. Number 17, we have the cube root of x squared multiplied by the square root of x. Probably easiest to just convert this into its fractional form like the last one, so x to the 2/3 power multiplied by x to the 1/2. In order to combine those, we need common denominator, so 2 over 2. Multiply the first one, multiply the second one by 3 over 3. That gives us x to the 4/6 multiplied by x to the 3/6. 4 plus 3 gives us x to the 7/6. It's hard for me to say sixths. It's a hard word for me. I don't know why. Next up, we have y to the 3/4 multiplied by y to the 1/2. So just multiply that by 2 over 2. So that's y to the 3/4 multiplied by y to the 2/4. 3 plus 2 gives us y to the 5/4. All right? And that is all of the first page. So let's then dive into this next page. So this is 2 square root 27. I like to simplify these ones first. So this is square root 9, square root 3. That tells us that 48 is divisible by 3. So that's square root 3, and then the square root of 16. 9 becomes 3. 2 times 3 gives us 6 cube root of 3 minus Square root 16 becomes 4. Negative 3 and 4 is 12. Square root's 3, so 6 minus 12 gives us negative 6, square root of 3. And this next one, we got a lot of simplifying we have to do here. 98, biggest perfect square that goes into that is going to be square root 49. That's 49 times 2. 49 becomes 7. 4 times 7, 28, radical 2, which tells us each of these is divisible by 2 here. Or actually, maybe not. This one, radical 25 comes out. That's 25 and radical 6. So this one becomes plus 5, radical 6. Radical 6 can't be reduced at all. And then the last one here, this is radical 16, radical 2. Radical 16 becomes 4, so negative 2 and 4 makes negative 8, radical 2. At the end here, you can only combine the ones with the same radicals, so 28 minus 8 gives us 20, radical 2, plus 5, radical 6. Nothing to combine with that 5 radical 6, so it just stays by itself. All right, here's the rationalizing the denominator questions, right? So we have the cube root of 5 here, so we're going to multiply this by the cube root of, what we need is 5 squared. So cube root 5 squared over cube root 5 squared. That gives us 20 cube root of 25 divided by cube root of 5 cubed, which those cancel. So then we have 20 cube root of 25 over 5. 20 divided by 5 gives us 4 cube root of 25. This next one is the fourth root of 2. So we need 2 to be a perfect fourth power. So that means we need to multiply it by 2 cubed. So fourth root 2 cubed over fourth root 2 cubed. That gives us 3. Fourth root of 2 cubed is going to be 8 over fourth root of 2. So that's the fourth root of 2 to the fourth power. Those cancel. We get 3 fourth root of 8 over 2. Alrighty, this next one, so this is fifth root of 3 cubed. So fifth root, we need to multiply by 3 squared. Fifth root, 3 squared. So that gives us 2, fifth root of 9, over, this is going to become 5, so we'll just have 3 in the bottom, right? And that's as far as we can take that one. 24. You could think of this a couple ways, right? You could think of this as 2 squared. Let's think about it that way. So if this is cube root of 2 squared, we only need to multiply by the cube root of 2, cube root of 2. So that gives us 3 cube root of 2 over the cube root of 8. So that's 3 cube root of 2 over 2. All right, almost done here, guys. So multiplying radicals, as long as they have the same index or same number out here, right? These are both square roots. We can combine them. So this is going to be x cubed and x makes the square root of x to the fourth. Y to the fourth and y to the 1 makes y to the fifth. Z to the 1 and z to the fourth makes z to the fifth. From here, you definitely need to simplify. X to the fourth is going to come out and become x squared. This is square root y to the 4 times square root y. And this is square root z to the 4 times square root z. Y to the 4 becomes y squared. Z to the 4 becomes z squared. So then our final answer is all of the things outside. So x squared, y squared, z squared. On the inside, just square root y and z are the only thing left in the radical. Okay, next up, 26. 26 is kind of tough. I like to combine the x's first. So x squared and x. So this is cube root. 81 and 8 have to stay. They have no number that comes out of both of them. But x squared and x would make an x in the top. Y cubed with y to the fourth would make y to the negative 1, right? But y to the negative 1 is really just y in the denominator. And then that z is also just in the denominator hanging out. Next, I would simplify the numbers. Cube root of 8 is just 2. Cube root of 81 simplifies out to the cube root of 27 times the cube root of 3. Cube root of 27 becomes 3. So this is really 3 halves multiplied by the cube root of 3x over yz. Okay, here's the hard part, right? We need to rationalize this denominator because there's a cube root yz in the bottom. So we need to make y and z perfect cubes. So we're going to multiply by the cube root y squared z squared over cube root y squared z squared. Why do we do that? Because if you check this out, right, now we have 3 cube root of 3x y squared z squared. Then that's divided by 2 cube root of y cubed z cubed. Both this y and z now come out. So we get a final answer of 3 cube root of 3x y squared z squared over 2yz. And now we don't have anything left in the denominator. Okay, last set of questions from 5.3 here. We always need to isolate the radical first, so multiply each side by 2. That gives us x to the 5 halves is equal to 32. Raise both of these to the 2/5 power. Nice part about this is we have x to the 5th root of 32 squared. 5th root of 32 is just 2, so it's really just 2 squared, which that then gives us x is equal to 4. So then you just have to plug 4 back into the equation, right? Let's think. 4 to the 5th power, that's a pretty big number. So 4 times 4 times 4 times 4 times 4, 1024. If you take the square root of 1024, let's make sure we get 32 out of there. Square root, yep. So the square root of 1024 is equal to 32. Then you go 1/2 times 32 to get 16. So 4 does in fact work. Awesome. So let's slide over to 28. 28 is another one of those that can be a little tricky. And let's talk about why. We subtract the 22 first. That's not tricky. So it's 3x plus 43 raised to the 2/3 is equal to 16. Now we have to raise both of these to the 3 halves power. Okay, that's going to cancel everything on this side, and you're just left with 3x plus 43. On the right side, though, let's rewrite this into its radical form. This is the square root of 16 cubed. We added this square root. Whenever you add a square root into a question, you have to put plus or minus. So in my next step right here, I'm saying 3x plus 43 equals plus or minus 4 cubed. Because it's plus or minus, we need to split it into its two cases. 3x plus 43 is equal to positive 64, and 3x plus 43 equals negative 64. X equals 7 on the left. On the right, x is going to equal negative 107 divided by 3. Okay? And you can go through and check these. I promise both of them work. All right? But it's always good to check, especially practicing checking one like negative 107 over 3. Hard to type into your calculator sometimes, so it'd be good to practice checking that one. 29, it says find and correct the student's mistake. So let's look through this. Well, it looks like right here, after this first step, all of a sudden they're putting parentheses around the whole thing and cubing it. Okay, well, remember you always have to isolate the radical first. So what they should have done is subtract 2 from both sides. So that would have given them cube root of x is equal to 2. And then they can cube both sides. So you get x is equal to 8. So honestly, they made the question a couple more steps than it probably needed to be. And then last but not least, we have question number 30 here. This you need to just square both sides. Gives you x plus 2 on the left. On the right side, you have to FOIL. So this is 2 minus square root x multiplied by 2 minus square root x. The most common mistake is people just try to distribute that square. Don't do that. Okay, you need to make sure you're FOILing in this question. So 2 times 2 gives us 4. 2 times the square root of the negative square root is negative 2 square root x. Negative square root x times 2 is negative 2 square root x again. And then 2 times 2, oops, we already did that one. We have negative square root x times negative square root x, which gives us positive x. All right, so this is equal to x plus 2. Negative 2 square root x, negative 2 square root x is going to become negative 4 square root x plus x. 4 in the front, x plus 2 back here. So we still have a square root in this problem. Because that's true, we need to isolate the square root again. So subtract x from both sides. When that happens, these go away. You get 2 is equal to 4 minus 4 square root x. Subtract 4 from both sides. You get negative 2 is equal to negative 4 square root x. And then you divide both sides by negative 4 to get 1/2 is equal to the square root of x. All right. Finally, we can square both sides here, and we get x is equal to 1/4. Alrighty. So 1/4, plugging this back in. Gonna be not the nicest thing ever, but let's do it. Square root of 1/4 plus 2. Does that equal 2 minus the square root of 1/4? Square root of 1/4 is easy. That's just 2 minus 1/4. On the left side, let's make this 8/4. So that's going to be the square root of 7/4. All right. Or, sorry, 9/4. My bad. 1 plus 8 makes 9, not 7. So that becomes 3/4. Or 3/2. My bad. Square root of 1/4 is 1/2, not 1/4. So 2 minus 1/2 does in fact give us 1.5, or 3/2. So x equals 1/4 does in fact work, and that brings us to the conclusion of this review sheet. As always, if you have any questions, message me in Canvas, ask me before the quiz. I would love to answer any questions about any of these problems. Other than that, I hope you guys have a great day.